Understand what is the image is and what is the object is, we have to work on up to some level. First we have to understand what is the object is. Object. Here in everyday life we come across with so many objects. Me, it's an object. But I am non-luminous. And second one is the self-luminous. Means what? The objects or which gives the light. Okay, but here we go somewhat deeply. Okay, anything which is giving light is the object. Okay, when we are studying the ray optics, we come across with two types of objects. I said objects are of two types. Here one is the point-sized object. One is the point-sized object and second is extended What I said, in ray optics we classify the objects into two. One is the point-sized object and second is the extended object. That means point-sized means what? Its dimensions are very small. Okay, so it's the point from where the rays are emanating like this. Rays are emanating like this. That means rays are going on. It is the point-sized object. And what is the extended object? For example, you take a optical element. Okay, it's a source. Here, this one is made of number of point-sized objects. That means number of points. If you take this razor, appears to be like this. If you extend, it might be in this way, and you can show it's like this. The same thing what I drew, I'm drawing there. That is okay. It is the what I mean is an extended object is made of number of point-sized objects. Here it's a point. Generally, when we are going to draw the ray diagrams, most of the time we take the point-sized objects only. Okay, to understand what is the image, previously I said, to form an image of an object, we must know what are the objects and as well as the images. And I think you understood what are the objects. There is the point-sized and extended object. Then after we are going to learn about the classification. Objects can be further classified into two more categories, and the one is the real object and second is virtual. The second one is virtual. Here indirectly I showed you what is the real object here. It is the real object. It is the object from which the rays appears to be diverging. Is divergent means moving away. I'm not doing anything new. I'm redrawing the diagram. Okay. Rays appears to be diverging is known as the real object. Real object is that from which rays appears to be, ray means light rays appears to be diverging. It's the real object. Okay, then what is the virtual object? See this? Imagine rays are coming from a distant object. See this? Okay, they are. I kept a optical element here. Optical element is nothing but a mirror. I kept a mirror here. Then what happens? You may understood. If you extend this, it incident on and as well as it also incident. Make these rays to meet at a particular point. Make these rays to meet at a particular point. This one is known as virtual object. Okay, we call it as the virtual object. Why it is called as? It is simple. If you watch this, you will understand. From the object, it is the real object, not reverse osmosis. It's the real object. Rays appears to be diverging. And watch this. The opposite thing is happening. Rays appears to be converging. Rays appears to be converging. Okay, it is known as the virtual object. Here in this way, we can classify the objects as a real object and virtual object. I hope you understood. From an object, the rays appears to be diverging. It is known as the virtual real object. Okay, where rays appears to be converging. It is known as the virtual object. It is a classification. Then after we have to know what is the images. Image is nothing but point of intersection of the rays. Is a point of intersection of the rays. You can understand this thing very easily. I hope you understood this. Okay, and we are going to learn about images now. I said image is the point of intersection of light rays. Again, these images are classified into two types. One is real image and second one is the virtual. It is the virtual image. Okay, images can be classified into two types. One is the real image and second is the virtual image. Okay, what is the real image? See this? I am redrawing the same diagram here. It is the mirror. Okay, rays are coming from a distant object, the incident on, and one more ray. Okay, then what happening here? We make them to meet at a particular point. Then after it is incidenting on, what happens? We have to follow the laws of reflection here. It is the angle of incidence and this ray get reflected in this way. That means it will move further like this. The same ray, here it incident, get reflected. The two will meet at a particular point. The two will meet at a particular point. This image is known as the real image. That's why I said is the point of intersection of the incident rays. Okay, point of intersection of the rays actually here. It is the real image. And now we will see what is the virtual image. See now, take one, what, optical element, and see, we took a point source here, and rays are the place is insufficient. I will draw here. Okay, I will make somewhat small. I will draw here. It is the optical element. I took a point sized object, and you know that it is the error object. Rays are coming from the incident only. Then what happens? They get reflected by following the laws of reflection. Means what? It is the I is the R. The same thing happens here. It is I and it is R. If you extend these rays backward, if you extend these rays, they might meet at a particular point. Okay, here it is known as what? Virtual image. If you watch it carefully, you will understand one thing. A real object, see this, a real object, the same thing I took. A real object forms the virtual image. And see, here the same thing will happen. Okay, a virtual object, it is the virtual object forms the real image. There is a relation between the two. A real object. Now we are going to learn about virtual image, where the image formation and virtual object forms the by a point sized object. Is the thing you have to come across with. On our class, you learned about. Watch it carefully. I think you understood what is the object and what is the image, and what is the virtual object and virtual image, and as well as real object and virtual image. And also you have learned that what a virtual object can form a real image, and real object can form a virtual image. Okay, now it is the time to formation of images. Okay, let's take an optical element, say it as a mirror. Okay, call it as an optical element. Then locate a point sized object here. Is a point sized object. I call it as object. Okay, already I told you point sized and as well as it is real object. Real objects can diverge the light rays. Take such light ray. Okay, this is light ray. One of the light ray we took, it traveled along this way and incident on. And take one more ray. We made it to incident on like this. These are the rays coming out from the object. Then you have to follow the laws of reflection here. What happens now? We have to drop a normal, and we dropped one more normal here perpendicular to the optical element. Let's see, it is the incident ray and it is the incident ray here. After this, what could happen? The incidenton, according to laws of reflection, the light rays must get reflected. Okay, this ray reflected like this, and if you watch this light ray reflected in this way. I'm very bad in drawing. Again, I am doing the same mistake. Okay. I'm unable to use the scale in proper way. This is the reflected ray. I'm making somewhat darker. Here I did the same. You have to draw a straight line. Okay, rays are, it is a real object diverging after incident-on, they change their path. That phenomenon is known as the reflection. What I am doing now, I am extending this ray further. I extended. In the same way, I extended this ray also. Okay. The two will meet at a particular point. We call it as the image. It's a real object and it is virtual image. Already I told you I am very bad in drawing. If I redraw the same thing, it appears to be like this. If I take the scale in a proper way, it might be like this. It is the image. If you watch it carefully, you will understand, okay, the properties of image formed by a point-sized object. Okay, it is the object and we get the same, it is the image. Join the two lines. That means join the object and image. Okay, look at a point, some x here. If you measure in a proper way, you will get Ox is equal to, actually I have tried it as XO. Why did I write it is, you will understand, and it is equal to Xi. Okay, XO is what? It is the distance of the object from the mirror. Object distance equal to image distance. That's why what's happening, if you stand in front of a plane mirror, you appears to be at the same distance inside the mirror. Just imagine you are moving towards the mirror with a speed of 2 meters per second, then what could be the speed of your image and what is the relative velocity of the object with respect to the image? Just think. Here is the object distance and it is the image distance. In the same way, if it is moving towards this, what velocity it has, the image also has the same velocity. Understanding me? And also the size of the object is equal to size of the image. That means what? We'll learn a new word here. In later section you will understand those things, magnification. Here the magnification formed by a plane mirror is always equal to 1 because image distance is equal to object distance. We'll learn about this in later videos. These are the image characteristics formed by a object, that is point-sized object. I hope you understood how to draw the image for a point-sized object. Here it is the plane surface. We drew the image, and what I am doing now, I am taking a curved surface. Let's say it's a curved surface. Okay, this surface is known as the convex surface. Then imagine a light ray came and incident on like this. What happens? Nothing will happen. It will change its path. The light ray changes its path. Actually, it has to move along this way. But this mirror, we call it as the convex mirror. What it did, it reflected the light. Okay. Here, angle of incidence is equal to 0 because the light ray is traveling normal to this plane. The same thing. Angle of reflection, it is obviously 180. Here, it came here and changed path. In the same way, now think a ray came and incident on like this. And what happens here? The same thing will happen. It will move in this way. It is the angle of incidence and it is angle of reflection. Okay? It is the application of what? Laws of reflection here. In the same way, if you take a concave surface, it is a concave. Keep a point-sized object here is put, and I drew a normal. And already you learned that if the ray falls in this way, it gets reflected. But ray is coming from a distant object. It's a point-sized object, incident on. And what happens to this? It reflects in this way. Okay, it is the image formation by a point-sized object. Later you will understand what could be the image position and what are the characteristics when the ray incident on any surface. Then after we will learn about the image formation by an extended object. The same thing you have to follow here. Let's say it is the optical element. We named it as the mirror, and we have to take an extended object. I told you extended object is made of number of point-sized objects. That means each point behaves like a object only. Imagine that one ray just one. Okay, the same thing will happen. We followed the laws of reflection. It get reflected, and also if you follow the laws of reflection here, it is the angle of incidence and it is the reflection. The same thing will happen here, incidence and reflection. Okay, draw a line, extend it, okay. If I extend this ray and this, there appears to be meeting at a particular point. It is the image formation by extended object. It also follows the same rules. What point-sized object followed? Object distance is equal to image distance and the magnification is same. Okay, it is about real objects and real images virtual objects and as well as the virtual image.